what work I'm presenting today is not my work, but it is from my group. So I'm here, so I take this opportunity to present it. So what we'll be presenting is preliminary experiment for introducing hands-on exercises for how do we teach or get students interest in the generative design techniques. So this, when I say students, I'm talking about the students from the design background, which doesn't have background in the generative design techniques. So mostly these are design students and the architectural student who won't have the grasp of this kind of technology. So this is the how the presentation will go, from the introduction to the methodology, and then we'll conclude towards the result. So I will start directly with the objectives. So there are 3 objectives: to highlight the importance of incorporating hands-on exercise in teaching generative design techniques to explore design possibilities, to investigate the patterns in the student thought process while applying any generative design technique to solve a given problem, to develop a kit and investigate whether the kit fosters confidence and interest in the generative design. So this is where first is where we are looking whether we can bring something hands-on to the teach, and when they are using this kind of kit, what kind of thinking, or whether this student use any generative design technique, what kind of things are going into their mind, what kind of strategies they are making. And third is to do that we have developed a kit and we provide it, and we see whether that is an effective way or not. So with the introduction, so what is generative design? Generative design is an iterative design process that uses computational algorithms to generate a wide array of design solutions based on specific constraints and parameters. And then designers select and modify these parameters, and then to get the desired outcome, designers have to intervene in, for the refinement to get the desired solution. So these are generative designs. When we talk about in a generic sense, not to the specific algorithm, so there are 3 components to this. One is a design schema. So design schema is how a problem is structured for a computational technology, or how designer is providing this, or how a algorithm is understanding this problem. So that is called the design schema. Then there should be a mean of creating the variations for the solutions. Then there should be a mean of selecting desirable outcomes. So there are 5 commonly used generative design techniques. Based on the review, these are cellular automata, shape grammars, L systems, genetic algorithms, and sound intelligence. So in this work, because of the limited scope, we don't go through all of these things, but in this work we have included cellular automata and shape grammar. So cellular automata is a grid-based algorithm, so that's why we have selected that. And to keep it simple, we have took the shape grammars, and others are kind of we can include in the future work. So in cellular automata, there are 3. So this is a generative design technique. There are 3 components to this. One is cell, one is cell state, and then there is neighborhood of the cells. So how it works is basically, so cellular automata is a collection of cells arranged in a grid of a specific shape, and each cell changes state on a discrete time state, and this happens based on the set rules of the neighborhood conditions of the other cells or state of the other cells around the any automata. So there are so these conditions you might be aware. There is one von Neumann condition where we don't look into the diagonal cells, and there is one which is Moore's condition where we have to look into the neighboring condition from all the neighboring cells. It is not changing actually. Okay, thanks. Okay, so the other generative design technique which will be considering into the experiments are shape grammar. So shape grammar has 4 components. One is the initial shape through which we generate the through which the algorithm generates the different design possibilities. Then there are a finite set of shapes, a finite set of rules, and finite set of symbols, and then the initial shape. So these are 4 components. How it happens is there is a set of shape rules, that can be applied to generate a set of language of design. So you see how, you see there is an initial shape, then based on the marker, which is the kind of, we have kept it easy here in the diagram. So it is a finite set of symbol based on which the rules are applied, and we get final design exploration of the solution by applying the rules with these initial shapes. So like there are different these techniques. So to proceed ahead, what we have done, we have kept a generic, we have given a generic problem to, we have defined it, and there are few constraints to that generic problem. So this problem is to design an exhibition space layout to display. So this is kind of a design of an exhibition layout where they have to show, they have to place different paintings. So there should be 4 partition of these complete space. The paintings are displayed on the stand such that there are adequate number of surfaces to show the paintings. Adequate space must be provided inside the zones for visitors to walk and view the paintings. The layout will be done. So this layout is kind of 2D. We are not looking into the 3D layout. There are requirements. So you see, okay. So there you see an example of the kit. So what we have is matchsticks as a panel, or we can call on which the paintings, we are assuming that the paintings are displayed on that. This set of these will be kind of a display structure. Then the view, so the constraints are basically the viewing angle has to be between 90 to 180. Then this panel are placed so that 2 sides of the panels, so both sides can be used for displaying the painting. So these are the constraints, and the problem is given. So based on this problem, we have now we proceed further with the 3 experiments. So there are 3 sub-experiments. One is free tangible design. So this is where we don't provide any rule, and we let the student explore what kind of solution they can generate for the given problem. Then second is the cellular automata tangible, where they have to apply the rules provided by us. Then there is shape grammar tangible. Then again will be providing rules for the shape grammars technique, and they will follow that. So here you see, okay. So there are different. You can see the right side, this 3 images which shows the grid. So these are basically cellular automata. Then there is in left the orange color one is the free tangible, and in between there is the shape grammar tangible. This is how they look in real when we are performing the experiment. So in cellular automata, so this sub-experiment has two activities. So one is the display structure. So these display structures are basically how we will connect a different display stand and make a structure. Then there is a layout plan. So now after making the display structure, how do we place this display structure into the complete layout to make the complete layout. So that is there are 2 sets of rules for this activity. We are using von Neumann neighborhood condition. Then there are 3 iterations being performed for both the activities, and participant will have 3 different layout after performing 3 iterations, and based on their they will be able to, based on their decision making and the requirement provided by the problem, they will be able to decide or reject the layout. So these are kind of the state 1 and state 2 we are showing, like either they, in this particular generative design technique, either they can use state A or state B, and this is how it will be on the grid, and based on the neighborhood condition they will be able to take either state A or state B. Okay. So there were we have made rules for this. Since I mentioned there are 2 activities, one is the how do we generate solution for the display structure, then another one is how do we plan the layout. So for both of these we have made rules. So these rules are like in real, these rules will be like how computers are using these rules to generate the design. But here to teach the algorithms, student has to understand like what is going behind. So these rules we have made in a way that there isn't any deadlock situation where these rules are not available. As these rules doesn't work, or there is a situation like they find themselves stuck. So we have tried to avoid that. and we have provided 2 set of rules for both the activities. In shape grammars, we see there are 2 sets of rules here also, again for like how it was in Cellular Automata, to make display structure and to design the exhibition layout. So here what we have is traditional one. For the first activity, we have traditional shape grammar rules to make the display structure, and the second is called the parametric shape grammar rule, where how we can partition the complete layout and how we can put the display structure. So to generate solutions for that, we have the second type of rules there. Okay, it is showing here, but there is some delay there. Okay, so this is how the protocol of the experiment is designed. So what we do, we provide them experiment handout. So here, like what I initially mentioned, there are 3 activities. One is free tangible, one is cellular automata, then there is one shape grammar. So we give them experiment handout, which is kind of print material. They go through it. Then we have video briefing to explain them this technique. Then we have doubt session after that. Then we provide them reference module. So this reference module is to explain them in between. If they have to see the rules, they can get into that. Then they perform the experiment with the kit provided by us. Then there is a feedback session. Then there is questionnaires. So we'll get more into this thing. So in methodology, what we have done, so we have selected 6 participants, out of which 4 are the design students and 2 have the architecture background, and we have made sure that they don't have they don't know the generative design techniques, so that we can avoid the bias, or we can check whether these things are really working or not. In data collection, we have used think-aloud protocol. So this is where while using this while doing these activities, they will be continuously talking about what is happening or what are they thinking, and we have video recorded that, and then we have analyzed the data. Then there is another 10-minute individual cognitive interview. Then there is a 5-pointer Likert scale also. So in data analysis, the whole experiment was recorded. Then we have done the transcription. Then thematic analysis is done by 2 of the researchers, and then they have generated the codes, and then with mutual agreement they have come with the 4 major things. So we'll talk about the results in few slides. Okay, so as I mentioned, there are 2 things. One is the thematic analysis, and another is the qualitative survey based on the Likert scale. So in thematic analysis, when they are performing the experiment, we have used the think-aloud protocol, and we have recorded whatever they are speaking. Okay, so so there are 4 major themes emerged from the thematic analysis. One is user or visitor experience. One is how. So while doing the experiment, they are thinking about the visitor experience. Then most of the codes are about how participants perceive the given problem for the better understanding. Then there is one theme which is about how their response to the provided GD technique, or whether they are doing the CA or whether they are doing the shape grammar, or how they respond to that technique. Then the 4th theme is how kid related to the real life problem. So this is where they are able to visualize in real what should be the layout, in real how should be the display based with this kit. Okay. So for the result for the qualitative survey based on the Likert scale, so this was done to understand the participants' experience and whether such a simple tangible exercise can generate confidence and interest in the students toward GD. The questions were formed into 3 categories for all the 3 experiment, like free tangible, cellular automata, and the shape grammar. In the context of in the context of subject understanding, like how well they were able to understand these 3 activities or 3 techniques. We had so I'll show the results here. Now you see. Okay, so there were the complete like, so this is for 6 subjects we are showing the result, and there are 3 set of questions for which we are showing this. So the first question was, has the experiment added the subject's understanding of the techniques? So whether they were able to understand this concept of, say, cellular automata, shape grammar, So you see here the result is, so this is on the Likert scale of -2 to +2, strongly disagree to strongly agree. So we see positive here. Then this whether they find the activity challenging or not. So challenging in the sense we are talking in terms of negative, whether it was they were easily able to do or not. So we see mostly the free tangible design, they find it challenging. So the reason was like they were given, there weren't rule specified, they were given freedom to explore by their own. So that's made it challenging for them. Then the third question was that the subjects find it comfortable to perform these activities the provided kit. So there we see the positive results from all of the subjects. Okay, so this is the final conclusion side. So this experiment framework, which includes such simple, tangible exercises and activities, so these generate confidence and interest in the students towards generative design techniques. The thematic analysis approach is utilized here to know the cognitive thinking of the students and how the domain-specific knowledge is essential and used in the design exploration. So in this case, we can count the domain knowledge about how to design the exhibition layout. So this current study highlights the importance of using tangible exercises to teach generative design techniques. The future work can build upon to make the develop a taxonomy of knowledge based on understanding of the thought processes of students, how they are, what kind of things they have in their mind while doing these activities. Then future work should include the other remaining generative design techniques also. Okay, thank you.